Hi all, we're going to go ahead and get started on our practice of solving systems of inequalities by graphing. But before we do that, I do want to make sure that everybody has done a couple of key pieces of information that we've been going over in class. Okay, so the first thing I want to be sure to talk about is that we understand that when we've been graphing, we've been getting everything into slope-intercept form. Now, we've been talking about y equals mx plus b for the most part, but now that we're dealing with inequalities, we're not going to have y is equal to, we're going to have y is greater than mx plus b, or we could have y is greater than or equal to mx plus b. We also could see ones that are y is less than or equal to mx plus b. Okay, so let's talk about again what that inequality symbol means when we see those. All right, so going over here to this little table that I have 4 different types. I have y is less than or equal to the graph. When it is equal to, so when it has this dash underneath, that is when it is going to be a solid line. When there's a solid line under that inequality symbol, that is going to be a solid graph. It also means that y is less than our graph. So I've just drawn a linear line here. It just happens to be increasing. It could be decreasing. So everything that we're going to do is going to shade below that. Since it's below my graph, it's going to be shading everything below the graph. Okay. Then when I have y is just less than my graph, it's going to be a dash line. But again, because it's less than my graph, we're still going to be shading below. Okay. Now, when I have y is greater than and equal to, or greater than or equal to my graph, it is going to be a solid line because it's got that solid line under the inequality symbol. That means it does include that line. And this time when it's greater than, we're going to shade above. Okay. And then when we have y is just greater than, it's going to be a dash line because it does not include the graph. The graph acts like a barrier, and we are going to shade above. Okay. I want to emphasize though, these little 4 black little graphs that I drew here, they are all increasing. I want to clarify, it could also be a decreasing graph. So any of them could be something that is decreasing. Okay. However, if it still says shade above, we're still shading above that barrier line. Okay. So just keep in mind it could be an increasing or a decreasing graph. The ones we're going to look at next is where it could be a horizontal or vertical line as well. Okay, so then let's go right down here to a couple pieces. Let me see if I can get in this area. All right, so now on this one, let's see if I can move this down. Nope. So when I'm looking at this section, if I have x is greater than a number, or even if x is greater than or equal to a number. Okay. If I have x is less than a number, or even if it's x is less than or equal to a number. What they're telling us is that they always want x to be that number. Okay. So let's pick an example. What if I had x is greater than 3? Okay. Well, our x value is always going to be 3. All right, our x value is always going to be 3. It doesn't matter what the y value is. The y is going to be maybe -2, -1, 0, 1, 2. It's that the important piece here is that x is always going to be 3. All right, if it's x is greater than, then that means it's going to be a solid line. If it's going to be, greater than or equal to, it's going to be a solid line. If it's x is just greater than, then that would be a dash line. If it's x is less than or equal to, it's still going to be a solid line. And if it's x is just less than 3, it's going to be a dash line. In any of these cases, x is always going to be 3. The y value will change, but the x value must always be 3 in these ordered pairs. Okay. When we do this, what we're going to end up finding is that these points are going to create a vertical line. Okay. So make a note of that here. It is going to be a vertical line. Or as we also learned for it to be called, was an undefined slope. All right, now the same is true when it's y is greater than some number, or y is greater than or equal to some number, or if we have y is less than some number, or y is less than or equal to some number. The thing that's different though is instead of the x always being 3, in this case, the y is always going to be 3. Okay. The x values can change. They can be anything from -2, -1, 0, 1, 2. But these ordered pairs, the y is always going to be 3. Okay. In this case, this is going to make a horizontal line or a 0 slope. All right, so now that we've kind of gone through some of that stuff, let's go ahead and get to our examples from the worksheet, okay? The examples that I'm going to be doing are number 3, number 5, and number 9, all right? All right, let me get my correct colors here so that I'm going to have green and I'm going to have purple. All right, so on this one here, we have x is less than or equal to 2. That means it is going to be a solid line. Give me 1 second, please. My pencil wasn't ready. Okay, that's going to be a solid line on that one. And our s value is, or our x value is always going to be 2. Okay. So I'm going to pick some values for y. I'm going to pick -3. I'm going to pick 0. And I'm going to pick +3. I'm not going to use that last one right now, but if I wanted to, I could do 5. Could be any value. Now I'm going to plot these ordered pairs. Now, if you've already understood and you can memorize that when it's x, it's a vertical line, you don't have to create the table. Okay, so then I've got 2, -3. So when x is 2, go down to -3, 2, 0, 2, 3, and I could even plot 2, 5. Now that I can see these points, I can see that these points are going to create that vertical line, that undefined slope. Okay. It's a solid line. Now, I'm looking for any values that are less than or equal to 2. Any values that are less than or equal to 2. Well, that's going to be values to the left of our graph. Okay, any values that are less than or equal to 2. I'm going to do that with the pencil. All right, now what I'm going to do is I'm going to go complete the second one. Well, the second one is x is greater than 4. It's greater than 4. That's going to be a dash line. Always my x is going to be 4. They didn't give me y in this example. They just gave me the x value again. Okay. Pick any y values. I always try to pick 1 negative, try to pick 0, and then 1 positive. So go ahead and graph these 3 ordered pairs, and let's see that we correctly pick a vertical line once again. So I have 4, -3, 4, 0, and 4, 3. Okay. this time it is a dash line. And this time its x is greater than 4, so any of the x values have to be greater than 4. So this time it's going to point to the right. Okay. Now that I can kind of see where I'm going to shade, I'm going to go ahead and shade this. Okay. And what I'm going to be looking for is I'm going to be looking where the two colors overlap, where the purple and the green overlap. That's where my solutions are going to be. Right? So what I'm looking for is any points that I can place where the green or purple overlap. So here, if I put a point there, is that a solution? Well, no, it's where the purple is, but not where the purple and green overlap. So it's not that one. What about putting one here? Well, it's where the green is, but not where the purple is. Okay, what if I put one here? Well, that's where neither color is. So is there any place that we can put a point where the purple and the green overlap? There isn't. So this one here would be no solution. There's nowhere on here that the two would overlap. Okay. All right, so now we're going to go on to number 5. Okay. All right, number 5, we have two equations. Y is less than negative 4x is our first one. Okay. So this one here is less than, so it's going to be a dashed line. Y is less than, which means we're going to shade below, because this one has a y and an x. And our y-intercept, well, there isn't one shown here, but that means that it's really just plus 0. Okay, so our y-intercept is going to be 0, 0, which is right at the origin. And then our slope on this one is going to be negative 4, or if you'd write in a fraction, negative 4 over 1. Okay, means down 4, right 1. All right, let's go ahead and graph that one. So we start at the origin, go down 4, 1, 2, 3, 4, right 1. Since we can't go down 4, right 1 again, what we're going to do is go the opposite direction. Is we're going to go up 4 from the origin and left 1. Okay. Go ahead and draw in our dashed line. All the way through our coordinate plane. And we are shading everything that is below this dashed line. The easiest way that I can think of to describe this, and I'm going to try to redo that dashed line because to me some of that looks pretty messy. Okay. The easiest way that I can think of to explain below the dashed line is by showing kind of like if it was a mountain. Okay, so if I was thinking of this as a mountain, and if somebody was standing on the mountain, now I'm not an artist by no means, so we're going to get stick people today. Okay. So if I drew a little person standing here, on the mountain, okay, where would below that mountain be? Would it be towards the left or towards the right? And you can see that small slant, very small slant that would show that what we're actually going to be shading is this piece over here. Okay. All of this side of the graph, that's all below the graph. Some optical illusion there, right? Because it looks like we're shading sideways, but we really are shading everything below that graph. Okay. All right, so now that we've got the purple graph situated, let's go ahead and do the green graph. Okay. or this second graph, our B equation. So on the B equation, okay, it is a solid line. Y is greater than or equal to our graph, so then we're going to be shading above. Our y-intercept is 0, -2. And our slope is +3. Okay, or 3/1. All right, so we're going to start at 0, -2. We're going to go up 3, right 1, up 3, right 1. Okay, we can go ahead and draw that line. Again, that is a solid line on that one. Draw our arrows at both ends. Don't forget to do on the other one. All right, now in this case, we're going to shade above. This one has a little bit more of a slant to it, so we can kind of see where that above area is. Okay, so pick up a green highlighter on this one. Everything above it. Everything from the green line shaded above. Now I know it doesn't look like this green line is over here, but think about it. That green line really does go on forever and ever and ever, right? So really, we are still shading above that green line. Right, so now what I'm looking for on this graph is I'm looking for places where I can put a point that's actually where the green and purple both overlap and are both solutions. Okay, so if I was to put a point over here, this point would not be a solution because it's not on the green nor the purple. If I put a point here, that's just on the green, so it would not be a solution. If I put a point here, that would be a solution because it is where the green and the purple overlap. If I put a point here, that would not be a solution because it's just in the purple. Now, what if I put a point here, same place as that dashed line, okay, or even here, again on the dashed line, those ones are still not solutions. The reason being is because that dashed line is just acting as a barrier. So it's saying it's holding it there, but it's not included. It's not equal to part of the information or part of the graph. Okay, it's just the barrier for that graph. Now, on the other hand, if I put a point on the solid line where it touches the purple and the green, then it could be a solution as long as it is where the purple and the green are. So this one here is right touching where the purple and green overlap, so that one is included and is a solution. Now here's what I'm talking about though. What if I put one on this part of the solid line? Can you think about why that one would not be a solution? Well, that one is not a solution because it's not touching where both the green and the purple are. Okay, that is only touching where the green is. Even though it's on the solid line, it has to be touching the green and the purple. Right, now that it looks like we have a bunch of little spiders all over our paper, what I'm looking for is the ones that are on the green and purple or are on a solid line that touch the green and purple. Okay, that could be a lot of different places. It's not just one in this case. Right, lots of different options here. Okay. So let's go on to number 9. All right, on number 9, we have two equations. Neither of these equations is in slope-intercept form. So our first job is to get them into slope-intercept form. Okay, so go ahead and draw our line. We're going to move the x from the right side of the equation to the left side of the equation. So we are going to cancel out this one, and we are going to have negative y is less than or equal to, now it's a negative x plus 4. Okay. Now, we have a negative 1 in front of that y. We have to get rid of that negative 1. The first way I'm going to show you is what we've talked about in class, is dividing by -1. When we multiply or divide, it's every term. Okay. So then we're going to have positive y. Now that we've multiplied or divided by a negative number, we have to flip the inequality. Then we have positive x and -4. Okay. That's one way to look at that. Okay, just dividing everything by -1. Now what I'm going to do is I'm going to go delete those -1s because one of you all pointed out a shortcut to me yesterday, so I wanted to make sure that I cover what you guys see. Remember, I don't teach shortcuts, but if you see them, you tell me and we go with them. On this one here, when you look at it, they're all negatives. So if I want the y to be a positive, I just multiply it by a negative, so that's going to become a positive. But if I multiply that y by a negative, the negative x has to also be made a positive. And this +4 is now going to be a -4. Okay? The only piece with this shortcut is that you have to remember when you do that, you have to flip the inequality. Okay? Because it's still like dividing by -1. So you have to flip that inequality sign. All right, so let's graph that one. So we've got our y-intercept is at 0, -4. And our slope is 1. Okay? Or 1 over 1. So we start at 0, -4. Go up 1, right 1, up 1, right 1, up 1, right 1. Okay? So if y is greater than or equal to, remember greater than or equal to is going to be a solid line. That goes on forever and ever. The shading, if y is greater than our graph, then everything we're going to shade is going to be above our graph. So ultimately, we're going to end up having to shade everything above our graph. Okay. All right, now let's go create that green equation. Well, with the green one, again, I have to go ahead and get y by itself. So I don't need the 2x on the left side, but instead I need it on the right side. So y is less than -2x plus 4. Y is already positive, so I don't need to multiply it or divide it by a -1, which means I don't need to flip the inequality. Our y-intercept is going to be 0, 4. And our slope on this one is going to be -2 or -2 over 1. This time it is going to be a dash line. Okay, so we're going to start at 0, 4. 1, 2, 3, 4. We're going to go down 2, right 1. Down 2, right 1. Down 2, right 1. Again, this one's going to be a dash line. And then we are going to shade this one. Y is less than our graph, so we are going to be shading below the graph. Everything below the graph. Now, by looking at this, what I'd like you guys to think about for just a second here, I'm going to label these 4 parts. Okay, so I'm going to go ahead and go through and label these 4 parts. This part, this part, this part, and this part. I'm going to label all of them by different letters, and I want you to think about which one, or if you've shaded, which one did you shade? Okay. All right, that's the wrong color, green. Okay, so I'm going to label this first one A, this top one B, this right one C, and this one D. So which one did you shade? Okay, Well, remember in class I talked about I don't usually shade. I usually draw these arrows just to kind of help me see where it is that I can look for my solutions. Because sometimes it's hard to see where the colors overlap. Not always, depending on what you're using to shade, but I use arrows. Now when I do this, I look for the box or the letter that has both arrows pointing in that direction. In this case, I can see that A has the green arrow pointing at it and the purple arrow pointing at it. So this would be the section where my solutions would fall. Okay. Anywhere inside this yellow area or on a solid line. Okay. Now if you look at D, D has the green arrow pointing towards its direction. C doesn't have a green or purple arrow pointing at it, and B has a purple area pointing in that direction. But I'm looking for the one that has both of them that would overlap, so that would be section A. Okay? So again, this one here. Would that or would that not be a solution? Well, that one would be a solution because it's the area that's shaded. What about this one here? Would that one be a solution? Yes, that would be a solution because it is on a solid line and it is where the areas that are shaded are. What about this one here? Would that be a solution? No, that one would not be a solution because that is on a dashed line. It can never be on a dashed line. What about this one here? It's on a solid line. Okay, it's on a solid line, but it's not where the areas are shaded, so it cannot be that one. Okay, one last one. What about here? Well, that is it would only be in one shaded area. It's not even part of the shaded area that I use for my example, so that one would not be a solution. Okay, all right, so different couple of methods that we looked at there and some notes. I'm going to go ahead and leave this here with you. If you have any questions, please reach out to me. All right, have a good afternoon.